So the next question is regarding arranging coins. So we have n coins. We want to build a staircase with these coins. The staircase consists of 6 rows, where the ith row has exactly I coins. The last row of the staircase may be incomplete given the integer n. We are required to return the number of complete rows of the staircase you will build. Okay, so let me just see the example of it. You can just simply see that n is equal to 5, where output is 2 because the third row was incomplete. That means we try to insert one staircase over here. If you just try to flip it horizontally, maybe like instead of this particular orientation where it is currently given, uh, if you could just try to flip it in the sense like just make it into this, rotate it like this way, rotate it in this way, then you could have such type of figure, and the value of 2, value of 3 would be occurring here. Now the value of 3 wasn't possible to achieve, hence we would simply say that the value the value of n, the answer in this case is 2, right? So what is actually happening? So the thing is that if n was given 5 to us, so if you could just see if this let's just assume if this had a coin, if this particular figure had a coin, then the number of coins would have been 1, 2 and 3. That means it would have been the sum of 1 plus 2 plus 3. In this particular case, if these 2 coins would have been present, that means the sum would have been 1 plus 2 plus 3 plus 4. So if you see the pattern, the sum is n into n plus 1 divided by 2. Yeah, this is the question. This is actually what we require. So we need such type of integer which has a value less than equal to the given n to us. For okay, it's creating confusion for n. So let's try to do it, and let's just say this is our answer A. So our answer A into A plus 1 should be the lesser, just lesser than the value of 2 cross n, where n in this case it was given 5 to us. Had A been 3, 3 into 4 would have given us 12, which is greater than 10. It would have been the answer. So the value of 2 is less than 10, and hence the value of 2 A is equal to 2 is the answer for this particular case. Let's just see to try to solve example 2 with this. So for example 2, we could see that uh, we could just see that suppose 4 were there, right? 4 were there, and right, this is a 4 times n is 8. So let's just try to satisfy if n is equal to 8. 2 into 8 is 16. So if we try to have 4, yes, 4, then 4 into 5 would exceed it, and it would be resulting in a value which is greater than 16, because 4 into 5 is 20. Hence, our answer is A is equal to 3, where 3 into 4 simply gives us the value of 12, which is less than 16. Hence, 3 is our answer in that particular case. So, we are required to find that particular value. Yes, that's the question. So, what we need to do, we go from for I is equal to 1, I I cross I plus 1 is less than is greater than n I plus plus. So we try to do this. So what we'll be doing is I if the value of if I star I plus 1 becomes greater, once it becomes greater, right? Once it becomes greater, so that is our point that we should be ignoring from that particular point. So this okay, this condition would make sure of that. This particular condition would make sure of that. Once it gets done, I would say I this should be equal to sign. This should be equal to sign. right? Because if it gets equal, then you would have need to another for loop, and when it goes back, this should be right. Then we return I minus one. Yeah. So this is the question. Let's see if it works or not. Okay, so let's just declare over here. Let's I is equal to one, and just a normal for loop. Okay, so I plus plus one into okay, it should be less than equal to one into two. This should be two. That for five, it's getting submitted. Let's just see if it works or not. This is a brute force solution. Okay, so this is a brute force solution. I could just simply see that this is a brute force solution. In order to avoid this overflow, we could simply just have two over here, and still the condition would be same. Still the condition would be same because I into I plus one would give us a value of either it would have either I would be odd or I plus one would be even or vice versa. Anything like both those cases would exist. Divided by 2 would definitely do that. Okay, so we are still receiving this integer overflow for this particular condition, right? So we are able to see that uh, this into this is somewhat giving us wrong an overflow condition. In order to avoid overflow, one of the tasks is basically trying to just make sure that just use long int. For this particular solution, what I would suggest is we try to think of something else. We try to think of something. Right. So in order to avoid those particular condition, this would definitely give us an order of n solution because we are moving it till order of root of n. It's roughly root of n. So we try to think somewhat a better approach in order to do that. And we could see that, yeah, we are having a math-based inequality. So let's try to think in terms of maths, right? So we are given a quality like a plus 1 is less than equal to inequality as 2n, right? So what can we do? It's just solving a quadratic inequality minus 2 star of n greater than 0, right? So what can we think of? This particular quadratic equation has two solutions. Yeah, one of them can be a negative, one of them will be a positive. So what are the conditions? If we talk about b square minus 4ac, then it's like 1 plus so it's like 1 plus 8 of n, right? Something like that. And if we try to think about it, minus 1 plus root of 1 plus 8n divided by 2, something like that, something like this. Minus 1 minus 1 minus so this would be a negative value, this would be a negative value, so we do not require this particular solution as the value can't be negative. Hence we can think of such value. This value would definitely provide us something. This value is like yeah, we can think about that and we can do something regarding this. So okay, this has particular solution which is root 1 plus 8n minus 1. So root 1 plus 8n. Let's try to have let's try to just use this particular formula that our solution is 1 plus 8 1. Let's try to simplify it a little. If it is possible, then we'll try to look for any of the methods. So what can we do is we bring our 2 over here, and that becomes 2n plus 1 by 4, right? And this becomes minus 1 by 2, right? becomes 2n plus 1 by 4, this becomes 1 by 2, and using this particular property I think we are able to get this particular solution. So this is an O1 solution, right? This is an O1 solution. This is an O1 solution. So what we'll do, it will be consisting of some float operations or double operations. I'll suggest you use double for accuracy purposes. Either of them could be used in this particular case. Sqrt. So this is Sqrt function. We have 2, 1 plus 0.25, 2.00 plus 0.25, right? Entire thing would be sealed, minus 0.5, minus 0.5, 0, and everything that we have done, this would be integer. This would be an integer, right? Because let's try to see if it works or not. Okay, so yeah, parenthesis, it works for this particular solution. Let's see if it works for the other rest of the solutions or not. Yes, it's fine. So we can just move on to the next question. That is plus 1. Okay, so the plus 1 is somewhat that particular question that we encountered previously. The only difference is we need to add 1 instead of k, it is now 1, right? Everything is just fine, everything is similar. What we did, it was everything was just the same. So we try to do it again, because even though we solved it earlier, but would still suggest you solve it again and again, because it is your practice and it would help you in grasping the particular concepts behind that particular question. So I think it's good. In case 1, int I is equal to 0, while I less than digits dot size. What we try to do is we simply move on further till our value is while I less than digits dot size. You could just simply say I plus equal to k. Yeah, digits I plus equal to k, and then similar thing, k is equal to 0, value of k is finished. Just we just need to do that carry thing over here. Carry, instead of declaring carry, I think we can do one thing. Instead of k will have the carry, k will have our carry, right? That could be one of the optimizations, that k is acting as our carry rather than declaring another variable for carry. So digits of I plus equals to k. What we can do is, after that, once we have received that this is a number, we can simply say, hey, digits I modulo divided by 10 will be our carry for the next particular traversal. And for this particular traversal, I need only the first value, that is equal to 10, and after this I plus plus. And if the value of k is still 1, or we could just simply say while k is greater than 0, what we need to do is we need to digits dot push back k modulo 10, k modulo 10, k modulo 10, and then this is k divided by equal to 10. This is it. We try to reverse it, and then yeah, that's just quality part we're looking for. Okay, let's see if it works for the test cases or not. It works, and yeah, this is the question. We have done this question as well. We can move on to the next question. Uh, Pardon me for changing the order of the questions, but yeah, it's one of the questions which are here. So we've done this question. We are doing plus one. We are doing plus one. Right, so there are some other questions which are left as well. So we are solving check if it is straight line or not. This is a quite easy question. You're given the coordinates, which represent the coordinates of all the points. Check if these points make a straight line in the xy plane. So it's a maths, it's a general geometry question. You know that all the points lie on a straight circle if the slope is same between each and every particular coordinates. The difference between the coordinates is same. Then what can we do is, if this is for general purpose, I'm trying to shorten the variable name for ease of writing. So if CDS dot size is equal to 1, it would always be false, right? That means we don't have any distance, or if it is 2. Let me just see if we need to handle such cases or not. Okay, so it's given that the size is 2. The size will be greater than 2, right? If the size coordinates dot size is greater than equal to 2, that means only 2 points will be present. So there will always be a line which will present between those 2 points that could be a straight line. And if the CDS dot size equal to true, then we could simply return true for that. What we'll be doing for the next cases is that we will trying to calculate the slope, or we should be taking as double. Double value could exist. We could have as CDS as value of 1, 1 minus CDS of 0, 1. So this is y2 minus y1, and we'll try to just yeah, we will try to do this division. We go over here, we have CDS 0, 0 minus CDS 0. This should be 0. The previous value should have been 1, 1, 0. So this is y2 minus y1. This is y2. This is y2. This is y1. This is x2. This is x1. The values which are being executed. Double slope is equal to this. What we can do is simply we can move further. Int I is equal to 0. I uh, I is less than 1, right? We have already done this entire thing for I is equal to 2, right? So we can move on further. CDS size I plus plus, right? What we can do is we could simply say that hey, if CDS dot CDS I1, we could just simply take this value, right? Copy, we say double this everything, double candidate slope, or we could C slope, expected slope, right? Anything, anything, anything would be fine. So we have done this. This should be I, this should be I, this should be I, I minus 1, this should be I, and this should be I minus 1. So we have calculated the temporary slope, the expected slope from that coming from the next set of 9. If slope not equal to expected slope, we simply return true. We have false, right? That means it cannot lie in the same line, else we return a true. It's working fine for this particular test case. Let's see if it works for the rest of the test cases or not. Okay, division by 0. Fine. So yeah, this is a particular test case that it's a corner case actually. So what happens if we have received such type of test cases where we have a 0 inserted as well? So if we have a 0 over there, right, that means there can be only two things. If we have origin as one of the points, if you have origin as one of the points, right? So you could just simply say that hey, either all of them should have 0, either all of them should have 0, or all of them should have x coordinate as 0, all of them should have y coordinate as 0. As simple as that, right? If it isn't possible, then we could simply say that what other test corner cases that could happen? What other corner cases that generally could happen? One of the corner cases can be if uh, we have such type of lines, right? We have such type of lines. where the slope is 1. The slope is 45 degree, right? Slope is 1. If you try to get this particular variable, and this would be 1 minus, this would be 1 minus 0, 1 minus 0. Okay, so this shouldn't cause a problem to us, right? This shouldn't cause a problem to us. The only problem that is happening is what if you get value as 0, 1 or 0 minus 1, right? What if we have such types of values? So if all of them has 0 coordinates, then we can simply say that it's a x-axis line. And if there is a vertical, okay, so there is only one case which exists. That is because of the x coordinate case, right? To handle the x coordinate case, the slope is generally infinity, right? Because it's a straight line. The y-axis, if some points lie over here, like this, points lie over here. This could be any line. This could be any line parallel to the y-axis also. This could be 3, comma 0, right? This could be 3, comma 0. After that, this could be 2, comma. This could be 4, comma 0, right? Okay. So this say this is a line we're talking about. This can be one line. 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 Right? These are all have infinity slopes, right? All are infinite. All have infinite. So if all of them have infinite slopes, then we can do one thing, and we can do one thing simply. If the division is zero, is like so. What we have observed is that all of them have the same x coordinates. All of them have the same x coordinates, as you can see. It gives this is x equal to 3, this is x equal to 4, 5, this is 6, this is 1. Only the y coordinates are changing, right? The x coordinates will be just the same. So we can just say that if x coordinate is the same, if the x coordinate is just the same, then we can simply say, okay, uh, right? We could just simply say that if instead of that, if CDS, if the value of CDS of I 0 equal to CDS I minus 1 comma 0, right? Uh, Double slope. Okay, so what should be done is this should be double slope equals to -1. For now, we are just calculating as -1, which is okay. The value of double slope can happen as -1. Double slope int max, right? This is called it int max because the slope exit slope is int max. So if such type of case happens, what we try to do is simply just expected slope equals int max. Else this happens, right? Right? If CDS of 1 comma 0 is equal to CDS 0 comma 0, then this would happen. Then slope is equal to int max. What had happened? Else, just say else the same thing. Double x slope value is generated here. Double expected slope and the same thing. Yeah, I think this will work. Huh? I think this will work. Okay, so we are missing something. Is okay, the 3 equal to sign should not have been present after. Okay, this works fine. Let's see if it works with the rest of the conditions as well. Okay, so it's providing some error. Okay, so yeah, of course we need to generate the absolute values, right? Absolute values are necessary. Absolute values are necessary, right? Trying to generate absolute values should be necessary. Absolute values should be necessary because uh, just in case if the vector hasn't any ordered elements, they are not sorted in same some order. So we definitely require them to have the absolute values of that. So if there is a line which has a slope as -1, it is the same, it lies on the same line which has the slope of 1, right? Because no, okay, it doesn't, because lines, right, right. What is happening in this particular case? Like -1, -3, 1, comma 0, 0, comma -1, 5, comma -2. Right. Rather than focusing on such values, I would suggest that instead of using a division format, let's try to use a simpler task that is, just to take the multiplication form of that, right? We could have int dx, which tells us to get value of CDS 1 minus CDS of 0 comma 1. There should be 1 as well. Right? Then we move ahead. We have int dy is equal to CDS 0 comma 1 minus CDS 0 comma 0. Right? So that what we can do is simply we can just move ahead. We could have auto I or anything, like we would to find CDS, just take those values as well. So if dx into okay, so what we can do is simply we can have v1 comma 0, right? In fact we should have v1 minus CDS of that was the first coordinate that should be in this particular case of 0 comma 1, right? 0, 1. If it is not equal to dy of 0 minus cds of 1 of 0 comma 0, right? This should be 0, right? That's just it. Then we return false, right? Then we return false, otherwise we return true. What is currently happening? We are checking each coordinate. And what is dx and dy? Simply because, like, as you know, like if you try to have coordinates as y and x, so y2 minus y1 upon x2 minus x1 should be equal to y3 minus y2 and x3 minus x2. So this has already been defined as dx, and this has already been defined as dy to us, right? So when we try to multiply it, this goes over here, this goes over here. So it is dx into checking the next coordinate. So y2 was the next coordinate. Here y1 we have taken as the first element of the first coordinate of that array is equal to dy. Dy is as it is. We have already given dy. Here the values dy and dx have been computed from the first two values of the array, right? And x2, this should be multiplied by x2. So x2 is our next array, the element which is coming up, or when we are iterating over that particular array. I1 is the first value of our I1, that is CTS 0, comma 0. And if this condition fails, then we could simply say that no, this does not lie with a straight line. Else, it does return that, yeah, so it's a valid combination when trying to do that. So let's just see if it works or not. This okay, so here we still have this condition that it's still providing us false because those values have something. Those values have. So I've tried to insert one more bracket, one more set of brackets. Try to see if it works or not. Uh, should work. Still isn't working. This condition that zero, 1 minus 0 is 1. Next set of iterations, as I could see, there was some problem in finding the coordinate system. Like it was a terrible mistake. So let's see if it works or not. Still fails. 1 comma 1. This should be 0 comma 1. Sorry, my bad. This will be 0 comma 1. Yeah, that's it. Feel confusing question. Do not deserve a lot of wrong answers. Okay, fine. So yeah, it's working. And let's just move on to the next question that is based on power of 4, right? Power of 4. Given integer n, return true if it is power of 4, otherwise return false. An integer n is a power of 4. You know what the power of 4 means, right? If there exists an integer x such that n equal to 4 is to power x. So as we did earlier, we could just simply do the same thing over here itself, and we have that virtual condition. We could simply say that hey, that int I is equal to 1, int I is equal to 1, uh, while I is less than n, or I is greater than equal to int max by 4, right? By 4. This should be by 4. By 4. If such thing happens, then what we should do is uh, we just simply say, hey, I let you multiply by 4, return I equal to n. That's it. Okay, what happens? Okay, no, something happened, something terrible happened. I will 4, 4, it's 16, 16 gets multiplied. Okay, what happened is I less than equal to 4, 16. So what's the value of I then? Value of I. Okay, if while I and should be and, right? Should be and. If any one of this condition fails, then it returns solution. Let's see if it works. Rest solutions or not, it should work. Yeah, it's working fine. The same case, like if you try to just copy this here and just do it for this particular case, it would be the same thing except the fact that Instead of I, it should be 3. It should be 4. Instead of 4, it should be 3. And this would work. This solution would work. Another solution was based on, these are all based on log 3, log base 3, and log base 4 solutions. Another of the solutions that might exist, and which you can see it over the discussion area, one of the solutions can be using taking log. So if you take a log using formula, if you can also provide this, but log itself is a like, it's a, the time complexity is logarithmic. So you can try to think, or you can try to use this particular function as well. It's your choice, but I would suggest you that this is also log based approach, and that is also log based approach. So it doesn't really matter, right? Okay, so we have done the questions. We have tried to solve some of the questions. Let's see what are the questions which are remaining. So we have done check with a straight line. We have done valid power of 4. We have also done power of 3, right? One of the questions that we are going to do currently is valid perfect square and rectangular overlap. After that, there are some questions left which we'll be doing. So one of them is factor trading zeros. This is a simple question which has been asked many times in the interview. One of them is ugly number. Then we have valid boomerang, and we have also a perfect number. So these are the questions that we'll be solving. After that, we have square root of x, x of a kind and deck of cards, count primes, Excel sheet, column title, reverse integer. After that, we have some bit manipulation based questions, which will be solved later on the further course of action. So yeah, that's just it. And